So, welcome back. In our last video, we actually got our particles up and going, and in this video, we're going to start bringing in our fluids. So, I'm in my dynamics menu, and I'm going to go here. I'm just going to say fluid effects, and I'm going to say create 3D container. So, I have a brand new 3D container. Now, if I wanted to, I'm going to perspective. If I wanted to, I could actually take this container and make it as large as I need it to be. So, right now, it's 10 by 10 by 10. So it's 10 cubics. So what I want to do, this is X, this is Y, this is Z. So let's make it higher in Y. And let's bring it this way. Now, one thing that I do not suggest doing is actually scaling this box, because it can mess with your voxel calculation, because we'll be using voxels for this. And that's just that's actually a type of geometry that is rendered in such a way. It's actually pretty interesting the way that it renders it. So I've got my fluid, and I'm going to click on my particle. So this is why I have my outliner open. So I'm going to click on my particle, and what I'm going to do is I'm going to go back to fluid effects and go to add edit contents, and I'm going to say emit from object. Now when I do that, my fluids are bound to the particles. And if I click on it right now, you can see, look, I'm emitting out some kind of, I'm emitting something, right? So you can see now I'm actually emitting something. So I've got fluids in that container, and my fluid container is filling up, but it doesn't look like it's following our actual pieces. So let's rewind this. Let's talk about some things with this fluid container. So when I made my fluid container, I had a container, and I have a fluid shape. Time is bound to that, and then also I get a fluid emitter. The fluid emitter is there because I took my particles and bound them to the fluid container. By doing that, it automatically creates a fluid emitter for me. So let's talk about what these settings in here do. So the thing that I'm going to be concerned with the most is going to be my fluid shape. Inside of my fluid shape, you can see it says it's telling me to keep my voxel square, and I've got a base resolution of 10. If I turn this resolution up, turn it up to about 80, you'll see that my kind of grid for my voxels got a little bit denser. That means now I have more voxels in here, and if I play this back now and actually look at this, you can kind of see where this is starting to follow the particles, and they actually have more interaction with the fluid now, because now I have more fluid inside of my container. Now what I will tell you is you do not want to jack this number up to something really high and then expect it all to play and work well, because turning up your voxels actually turns up resolution, which in turn makes your simulation run slower. So I usually run on my system. I can run it at about 100, probably about 80 to 100, and you can see now that I'm starting to get some wispiness to the fluid, and it's not just coming up and everything else. I'm starting to get something actually happening with that fluid. So if I were to do something, I can see right now my content method is currently being based off a dynamic grid. Velocity is based off a dynamic grid. I'm not using any temperature or fuel in this right now, and my color method is using shading color. I could make it a dynamic grid like everything else, or not. So I'm going to close contents. I'm going to open up display. Display is going to show it shaded as rendered, and then I've got a slice per 2 voxels. I'll put this down to 1. I want to have a slice at every voxel, so 1 voxel gives me a slice. And you can see these guys you can see they're interacting with the fluid. They're picking up some of that fluid and squishing it around. And I can look at my dynamic simulation. I have gravity in here, viscosity, friction, and damp for dampening. And then the solver is the Navier-Stokes solver. I'm going to leave that to where it is and leave everything else where it is. And if I wanted to simulate liquids, I could turn on this and get a simulation for liquids with these. And I also have this Auto-Resize. Now the Auto-Resize is very interesting, because right here I set this to 100. If I turn on Auto-Resize, it kind of deactivates this part of my container properties, and this becomes the new container property. I'm going to say Auto-Resize margin at about 3, and then I'm going to leave everything else the same. And right now it's saying max resolution is going to be 200. The nice thing about using your Auto-Resize is that you can see that it will resize itself to where your particles are currently at. And since my particles die way up here, it doesn't go any farther than that. So that's pretty nice. Because in the end, we'll turn off this bounding box and you won't even see it when we render this. And I've got self-attraction and repulsion, how the fluids attract to each other. But the most important thing in here is going to be content details. My content details, well, they pretty much do that. They give details to the content inside of the fluid container, such as density. I can turn my density up, and now you can see that I can actually see more dense fluid inside of my container. I can see it kind of bouncing around and giving me this nice look. I can add dissipation, so I can make these fluids dissipate sooner. So if I come in here now, you'll see they dissipate really, really quickly. By the time that they're actually being emitted, they're almost about to disappear. So one thing I want to do, because I don't really need to see my particles to know that they're actually working anymore, I'm going to click on my particles and I'm going to hide them. So my particles are hidden now. I don't really need to see my particles. I'm just using the, because the only thing I'm doing is using the motion off of my particles. So I can see dissipation is pretty high. It's pretty wispy. Go to my fluid shape, and let's turn dissipation down to maybe like 2.5. So now we'll have a little bit more before it dissipates. And let's turn the scale of this up. And you can always extend this over what it is. So right now I'm seeing it at 5. That looks pretty nice. I've got like these wispy, nice little wisp stuff going on with this. I also have velocity in here I can change. I can change how this swirls. I can add noise into it. I can add turbulence into this, so I can bring in a sense of turbulence into the fluid itself. The one thing I want to do, because I'm actually tired of seeing that box jitter around, I'm going to come back and I'm going to come in here to display. And right here where it says boundary draw, I'm going to say none. And you can see now the only thing I see are my actual fluids, and I don't have to see the box like bouncing around. So I can see my fluids. I've got fluid emitted, and the fluid's being picked up by the particles and kind of pushed around. Let's go back in here to condensed display. I can go in here and turn up things like my density tension, make it a little bit tenser around that. So you see it can either be more tense or less tense, and by doing the tension, I'm actually kind of keeping that fluid together longer. And I can turn up diffusion so that it diffuses a little bit more. And I'll turn up my density scale a little bit more. Alright, so my dissipation, let's bring that down to like 1. So now it won't dissipate as quickly. Alright, so one thing that I want to do is I have my fluid shape, but I also have a fluid emitter. So I'm going to click on my fluid emitter, and let's look at some of the things in here. If you look, this emitter looks a lot like a normal emitter for particles, which it kind of is. So I'm going to tell it I want to emit 200%. So I've got way more particles being emitted now. So all those particles are being emitted out. And right here for fluid attributes, you can see the density method is set to add. I'm going to add, let's say we add 5 density voxels per second as one is being emitted. So you can see now, look at that, I'm getting way more density out of my particles. So this is now adding more voxels as the simulation goes on. Go back to my fluid shape. And let's go in here to density scale. Let's bring the scale of this down some. And let's actually turn the dissipation up. So we're going to do it at like 2. So we'll dissipate it at like 2. And let's even turn that tension up a little bit more now. Alright. Let's go back to my fluid emitter. And some other things in here that we can see. I've actually got some turbulence that I can add to this. So I'm going to turn on turbulence and make it a little bit more turbulent. Now the turbulence is this right here is going to be for the emitter itself. So the emitter is more turbulent, and I think I like the way that looks. Let's maybe add maybe 10 per second so we can get some thickness to this. So I've got these particles being emitted. These particles are being emitted. They're interacting with the fluid, and this is the result that we're getting right now. So I'm gonna go back to my fluid shape, and let's look at down here for lighting. I'm gonna go down to lighting and say self shadow. Now when I turn on that self shadowing, this is where things start to get cool. And let's turn it back so we can see this in a, there we go. So, and I can hide the rest of this stuff too. I don't need to see my axis or even my curve. I don't need to see any of that stuff because now I've got those guys got them generating in there, so that's good. So on my fluid, let's go back and click on my fluid. I do need that selected. Going back to my fluid, I'm going to go in here to the Auto-Resize, and I'm going to say my auto margin. I'm going to set it down to like 2, and max resolution. I'm going to leave it where it's at. And for a second, let's just turn off Auto-Resize for a second, and I'm going to look at this at 110 resolution. By turning off Auto-Resize, it'll be the size that my box originally was, and I can see what that looks like without it auto-recalculating the fluid method or the amount of fluids in there. So I like the way that looks. And if I look at self-attraction and repulsion, I'm going to say this is based off of density. And let's actually stop it and then let's stop it, rewind it, and now rerun it. So I can see that this will self-attract. So they'll be attracted to themselves more. Makes my simulation run slower, of course. Let's turn it off for now. And I'm going to say content details. I'm going to look at density. It's going to make it a little bit more dense. Let's say we let it dissipate less so it lasts a little bit longer. Or it can dissipate more and it'll die quicker. And you see it kind of, if it dissipates quicker, it kind of follows right up against the actual particles that it's on. And I can turn my tension down. So there's less tension, density tension, and I can even institute noise into that if I wanted to. Let's turn on the gradient force as well, and let's make it dissipate more. So now I've got this softer, kind of wispy stuff going on, and I've got the lighting still turned on. I'm gonna go right here to lighting, and lighting is all that stuff still turned on. I'm gonna go in here to where it has shading at, and you can see I can change the transparency. That's what my voxel really looks like. But by instituting some transparency into it, I'm actually able to see what this looks like. So I can come in here and actually play with the opacity or the transparency of the overall thing. Now my color is being controlled by just this color. I'm going to set this color to density. And for the white, I'm going to click on it. Now since my simulation is running, you won't see the changes of the color in this until I stop it. Now it'll show the changes in the actual fluid, but it won't show the change on this. So you can see right now it's still stuck at white. And I'm going to come in here and bring another one in here for white. And let's do this one at purple. So right now this is based off of density. If I stop this really quick, and you can see I've got the two colors that I'm supposed to have. So you can see that this right here is dense on the tips of this, and I can actually push this one way or the other. So now I got a little bit of a mix between those two colors, which is kind of cool. And I'm going to make this smooth. So make this a smooth transition between these two. And you can also base this off of the Y gradient or an X gradient or a Z gradient. You could base it off of center gradient if you wanted to, or a constant. Or, as we already had it, I'm going to do it Y. So this right here is kind of my Y. So you can see at the end of it, at the end, it's red, and down near the base, this is the purple that I have. Now, the cool thing is that I can also come in here and use incandescence. Right now, my incandescence is set to temperature. I'm going to set my incandescence to, let's say, Y gradient. And I'm going to just kind of push this around like that. So I've got this like really cool looking stuff going on here. And you can see once again I've got the opacity setting that I can set in here, and that's my whole density of my box. I'm going to bring this down though. And I can even play with how dense this is. I can make it more dense. You can see I've got that going on, or I can make this less dense and I've got more like wispiness going on. But you can see I've got these individual kind of happenings. And instead of using, go back up here, instead of using this, I'm going to go back and turn on the Auto-Resize. That way it'll resize itself however I need it to be. And you can see there are my particles. My particles and my fluids are interacting with each other. They're generating out. Gives me some really cool effects. Got like this smoke dragon thing going on, or a smoky thing going on here. So I've got some really nice effects that I was able to do with this. And even with my transparency here, I can set this to a drop off. I can set this to a Y gradient. If I turn this up, you can see it just basically drops it off on basically on a Y. I'm not going to use that. And I've got like a matte opacity, and in my shading quality, how well is this going to shade? You know, I'm going to set this maybe not to 10, but let's say we set it to like 5. And sampling method is going to be adaptive jitter. Let's leave it that way. Let's do a smooth render interpolation. And then my textures, I've got texture color, texture incandescence, and then texture opacity. And then my texture type is going to be a Perlian noise. I can make this a billow or whatever else. When I render, well, this is when I render this out. So if I come in here and I actually render this and see it, so let's see what this actually looks like rendered. So this is my rendered object right here, which is actually really pretty cool. So this is actually really pretty nice. It's interesting stuff going on with this guy. And that's really kind of it. You know, I've got the fact that I can turn up my shadow inside of here. I can turn up the shadow diffusion. I can make it a little bit more diffuse, a little softer. And I can change the brightness of my light that's inside of this, and the color of the light. And then I also have an ambient light setting in here, so you can see my ambient light, and then how my ambient light diffuses through everything. I can change that diffusion as it goes through. And I'm using, I'm using a real light when I do this. So I've got my fluids. Let's say I emit maybe 20 per second. Let's do it like that. Now you can see I've got a denser. This is a lot denser when it comes to my fluid. So got that kind of knotting up on itself and twisting around, and you can see this kind of just go at it, which is really cool. Now, since I've got, you know, this is all driven by particles, you know, I haven't even really changed anything with the particles. So if I came into like my particles themselves, I could emit more particles per second. I could give them a different lifespan. So I could say that they live to like maybe 3, and you know 1.5 will be their random death. So now I can see my particles are going to live longer before they die. So now I have a totally different effect with this. I could go back in here and go to my fluids. Let's stop it. Go to my fluids, and I could change the dissipation. So I can come in back in here and go to my content details, go to my density, and I can turn my density up. I can turn my density down. I can even change how they dissipate. So let's say we dissipate at 10, so it dissipates a lot quicker, and I get this kind of random, fluffy, whatever this is. And I can add noise into this, get random noise. Let's turn my density scale back up. I'm going to want density scale at like 10. I can even change buoyancy, so I can make them more buoyant, as if my is in more in water. And you can see with it being more buoyant that it's kind of keeping itself close to itself. And let's turn on the tension more and the tension force. So you can see I'm getting a totally different look out of this kind of smoke, magic smoke stuff that I've got going on here. And that is fluids. Those are fluids. Not in a nutshell. There's way more things you can do with fluids. You can have water simulations. You can have clouds. You can do 2D fluids, which are a lot less taxing on your system. So you could have a 2D plane of clouds and just have them parallax behind that. So there's tons of things you can do with your fluids. And hopefully you will get something useful out of this. And I will see you in our next series, which I'm kind of doing some random things right now, so I'm probably going to do some more things with dynamics and some more things with some of the dynamic functions inside of Maya. I've been a huge Houdini user over the years, and I just kind of blew the dust off of Maya and got back into Maya because I'm starting to learn Python a little bit more in depth, and I want to be able to do some Python stuff with my dynamics inside of Maya as opposed to doing everything inside of Houdini. So yep, this is just the start of what we'll start doing with these really cool fluid effects and dynamics inside of just Maya in general. So I will look for you in our next video series.